right. Hi, everyone. This is me, Rehan Machi, Lily Yeager, Ellie Hosokawa, and Mengizem Tazal from the Biomedical Engineering Society Diversity and Inclusion Committee. So, just to outline our booth, we will be talking about how diversity and inclusion plays an important role in design, and we hope to leave you all with a better sense for why diverse teams are necessary in biomedical engineering. So, first things first, you might be wondering, what is biomedical engineering? Well, just a broad definition is that it is the application of engineering principles and design concepts to medicine and biology for healthcare purposes. Now, this is a very broad definition, and it encompasses a lot of different fields and a lot of different devices in healthcare. Biomedical engineers work on simple devices like tongue depressors and band-aids, as you can see on the left, and work up to more complex devices like the blood glucose sensor for people with diabetes on the bottom center, and the automatic blood pressure cuffs that you would go use at a routine checkup. Biomedical engineers also work on medical imaging applications like the classic x-ray that you get for when you break your hand. Now, I'm going to pass it on to Ellie, who is going to talk about Dni Committee Efforts and why Dni is important in biomedical engineering.
All right, thanks, Rehan. Hi, everyone, I'm Ellie, and like Rehan mentioned earlier, we're from the BME Diversity and Inclusion Committee, and we are a student-run organization that aims to promote an inclusive environment in BME, and we want to make sure that voices of underrepresented groups in engineering, whether that be people from the LGBTQ+ community, women, and people of color, are heard. Listed here is our mission statement, as well as the link to some of the initiatives we've been working on this past year. And our committee was formed this past summer. And our committee was formed because diversity in engineering really matters. More diversity in engineering means not only are more opportunities available to historically underrepresented groups in engineering, it means that more ideas are brought to the table that can help solve problems for all groups of people. Next, Rehan will go over some of the examples of engineering designs that are currently not inclusive of all people and need more work and improvements.
Thank you, Ellie. Here, we just wanted to give you a couple of examples of designs and technologies that still need some work and some solutions in terms of inclusion. So the first design that still needs some work is the simple Band-Aid. Band-Aids are designed for Caucasian people with lighter skin tones so that the Band-Aid blends in with their skin and looks way more discreet. This does not work for people of color with darker skin tones, and Band-Aids are very noticeable on them. The second technology that needs work is facial recognition. If you've used an iPhone or a smartphone that uses your face to unlock it, you've witnessed this technology, but a very basic form. Some of the more complex forms for different applications do not work well on people of color. This is a field that is exploding, and we definitely need diverse teams to solve this problem. Another common device that could use some improvements are surgical tools. Surgical tools were primarily designed with the male hand types in mind and are not always suited for female hand types. On top of these examples, there have been many reports that have shown that women are disproportionately more harmed by medical devices than men are. So as you can see, in the medical field, there are a lot of D&I related problems that need to be solved and could use the expertise of diverse teams with differing backgrounds. Now, I will pass on to Mengizem, who will talk about our design challenge.
Thank you, Rehan. Engineering is problem solving, so here's a scenario to help you explore your engineering abilities while considering the role that this diversity and inclusion is within the BME department here at UW-Madison. The design challenge activity here is to create a helmet for someone that has an afro. An afro is a hairstyle in which naturally kinky or tightly curled hair is styled in such a way as to stand out all around the head. If you're wondering how this is biomedically related, think of it in terms of preventive healthcare. Just as we brush our teeth to prevent disease, we wear helmets to prevent physical injury. Common challenges that wearing a normal helmet presents someone that has an afro include the helmet not fitting on snugly and the inner padding Velcro locking onto hair, which can hurt when you're trying to put on the helmet. In the black and white image, notice that the stunt biker with an afro is not wearing a helmet. For this activity, quickly sketch a helmet design that you think would minimize discomfort and maximize safety for the stunt biker with an afro. Once you're done, share your design ideas with your peers and also with us through email or on the committee's Instagram page. Both are listed here. You can now pause this video for 3 minutes and attempt this design challenge.
Hopefully everyone had enough time to work on this design challenge. Personally, I've been working on this exact design challenge with a team over the past couple of months. It has been observed that wearing a bike helmet reduces the risk of head injury. However, there's an absence of bicycle helmets on the market that accommodate hairstyles traditionally worn by African American individuals, placing them at a higher risk for injury. Hairstyles that these individuals wear are often larger in volume, texture, and curl compared to traditionally European women's hair, which causes the helmet to be ill-fitting and to sit higher on the head, which can be seen in the first picture on the slide. The current solution is often to purchase an oversized helmet to provide extra room for hair. However, this is insufficient as the increase in size of the helmet can compromise safety. In addition to decreased protection, materials that the bike helmets are currently made of, such as Velcro, can be damaging to fragile hair. The team aimed to solve these problems by creating the double-decker design. This design incorporates a second tier or dome-like structure to accommodate a variety of hairstyles, such as high buns and natural hair. This can be seen in the second picture. The team simulated the model with a program called SolidWorks and is currently testing it against existing helmet models. In addition to the model, the team selected 3 materials to test as possible fabrics to line the helmet interior, including satin and silk, which are pictured in the third picture. In the future, the team plans to conduct more testing and will hopefully be able to build the helmet soon. Overall, we need engineers from all backgrounds in order to tackle the greatest engineering challenges, and hopefully there's at least one thing each of you can take away from this presentation. Thanks for listening.